Okay, now I'm going to introduce uh, how to sketch a graph of log. Okay, log graphs. Okay, the standard function of log is y equals to log base ex. Okay, so if I have a graph looks like that. The log graph pretty much looks like this. Okay, this is 1. Okay, and I have a vertical asymptote this case. And which is x equal to 0. This is asymptote, and well, as I can say from the graph, as x approaches to 0, y approaches to as minus infinity or infinitive. Okay, and the domain of the standard log graph is x belongs to all the positive values, okay, from 0 to positive infinity, or I can just label it x belongs to r plus all the positive real value. Okay, there's two ways to label it. Okay, it's again with knowing the standard log graph, you can sketch any log graph by using transformation. Okay, now I just do some examples on graph sketching. Okay, for instance, if I want to sketch the graph y equals to 5 log base e x plus 2. Okay, let's make it interesting. Minus 5 times log e log base e x plus 2. Okay. First, let's describe the transformation of this graph. So we have a reflection on x-axis. Okay. Also, we have two dilations. Okay, here, sorry, only one dilation. Okay. So dilation by a scale factor of 5 along y-axis. Okay, and a translation which is 2 units up. Okay, so the graph would looks like. Okay, let's concentrate on the reflection first. So it's going to be reflected on x-axis. So the graph would have the asymptote won't change, and I would have a graph looks like that. Okay. Dilation by scale of factor of 5 along y-axis means it's going to be stretched vertically, and the whole thing moved 2 units up. So basically, okay, I have let me label the asymptote first. X equal to 0, and the graph should be looks like this. Now we have one x-intercepts, and let's find it. So x equals to 0. Okay. Sorry, y equals to 0. Y equals to 0, and let's say 0 equals to minus 5 log base e x plus 2. We can rearrange this formula. So log base e x is equals to 2 on 5. Okay, we move the minus 2 to the other end and divide by minus 5. So I have 2 on 5. And x is going to be e power of 2 on 5. Okay. And here is our x-intercepts. So I just label it as e power of 2 on 5. Okay, and yeah, that's the graph. Y equals to minus 5 log base e x plus 2, and the domain is x belongs to all the positive real values r plus. Okay. Also, from reading the standard graph, okay, we also can find out that log base any number, okay, x, okay, cannot become 0. Okay. Okay. This is very important here. Okay. Okay, now let's do another question. Okay. Now let's sketch the graph y equals to log base e minus x plus, okay, bracket minus x plus 5 and plus 1. Okay. Okay, let's make it harder. Log base e bracket minus 2x plus 6 plus 1. Okay, now let's sketch this graph. Okay. Firstly, let's just describe the dilation first. Okay. And the domain of the graph should be from 0 to okay, let's label the domain after we draw the graph. Okay. Let's describe the transformation. Because the coefficient of x in the bracket is a minus number, okay, and there is a reflection on y-axis. Okay. Second, after the reflection, let's say I found the dilation there, the coefficient of x. So we have dilation by a scale factor of half, which is 1 on the coefficient of x in the in the bracket, okay, along x-axis, okay, and now I have two translations, so I move 1 unit up, and I moved the horizontal movement is to make whatever in the bracket equals to 0, so I have minus 2x plus 6, okay, equals to 0, x equals to 3, so the horizontal dilation, the horizontal translation is 3 units to the right. Okay, now let's now let's start to draw the graph. So from the original graph, look at the standard graph here, okay, after we have a reflection on y-axis, I will have a shape like this, okay, and the dilation by scale factor of half means the horizontal the graph is going to be half in horizontal distance, okay, and again we moved 1 unit up, so okay, the whole thing moved 1 unit up. The asymptote doesn't change, but when we move 3 units to the right, the asymptote changes. The asymptote become y equals to 3 instead of y equals to 0, because we move the whole thing, x equals to 3, okay? Because we move the whole thing to the right by 3 units, so the asymptote changes. So first I sketch the asymptote at here when x equals to 3, okay? Before it's at x equal to 0, and I sketch, okay, let me sketch the graph. It should look like that. From the graph I can say it cuts the y-axis and also the x-axis, so I will have a y-intercept and an x-intercept. So let's find the intercepts, okay? So x equals to 0 for y-intercepts, I substitute x equals to 0 into the function. I will have y equals to ln 6 plus 1, okay? And so this should be our y-intercepts, ln 6 log base e6 plus 1, okay? And I can label the graph in this form because this is the exact value of y-intercepts, okay? I don't have to change it to decimal number unless the question specify, okay? Now let's find the x-intercept. So I make y equals to 0, and I have 0 equals to L